All right, so Unit 9 starts with polynomials, and before we actually start with page 5, because this is page 5, go back one other page and you'll see some words up here, how we actually name polynomials. So polynomials actually have a name based on how many terms you see in the polynomial. So let's just go through the vocabulary first. So if there's only one term, we call that a monomial. If there are two terms, binomial. Three terms, trinomial. And if you have anything after a trinomial, that means anything after three terms, we just consider it a polynomial. Okay, so those are the words. So if you have an expression, so they'll be giving you guys expressions that look like this off to the side. So they'll be giving you these expressions, and then they'll ask you to name the type of polynomial you see. So if there's only one term in the polynomial, then you go by the terms that you see on this side. Okay, that's how you name it. Okay, so if I say if it has two terms, then you'll say that is a binomial. If it has three terms in it, you'll say it's a trinomial. And then anything after tri, we'd really just call it a polynomial. Okay, so if it has four terms in it, then you just simply say polynomial. Okay, we don't have a special name after three. Here in this column, you'll see it says degree. The degree is based on the exponent. Okay, now the exponent for the variable only. Okay, so that's why you see the degree is 0 here, because there's not an and I should say the exponent for the actual variable term, not the number. Okay, so this is just for variables. Here you see the degree is 1 because this exponent for the variable is 1. Here you see a 2 because the highest degree for that particular variable is 2. So you don't add the exponents together. So you don't say it's x to the second and x to the first. You just choose the higher or the highest out of the terms. Here you see the degree is 3 because that is the highest exponent for that particular variable. And here you see the degree is 4. So if I ask you what is the degree, then you're looking to see if there's a variable in the problem, and whatever the highest exponent there in that will be considered the degree. Okay, so all of that's important because you'll be asked to determine the degree and you'll be asked to name the polynomial. All right, so let's go over to this page here. So besides naming the polynomial and the degree, it also says rewrite in standard form. Okay, standard form simply means you always write your polynomials in the order of the highest exponent. So like I would put this in standard form by rewriting the 2n to the third term first, then the n to the second term next, minus the n to the first term. Okay, so that's how you actually put it in standard form. You go in descending order of the powers. Okay, descending order. So from highest to lowest. Okay. All right. So let's move on to number 2. Well, first let's go back to number 1 because we have to now name it. I have 3 terms here, so this will be called a trinomial. Okay, your terms are separated by the plus signs and minus signs. That's 1 term, 2 terms, 3 terms. Okay, now if I had another term, a 4th term, let's say it was plus 5 at the end, then I would have just said polynomial because we don't name it after 3. Okay, the degree, what is the degree? What's the highest degree in this particular trinomial? 3, so that is the degree 3. Okay, we get that right from there. Okay, you don't add the degrees together, you just choose the variable that has the highest. All right, let's do number 2. So we're going to put this in standard form. So put the higher exponent first. Okay. We're going to name it as a binomial because there are two terms. And the degree is 4. Okay. Number 3, same thing, put it in standard form. So I'm going to start. Now notice there's a minus 8x to the third. So that's going to be negative 8x to the third plus 4x squared plus x plus 8. Constants will always last because the degree of the constant is 0 because it doesn't have a variable. Okay, this one has 4 terms, so we're going to call it a polynomial. And the degree here is 3. All right, so for number 4 is only 1 term, so that's a monomial. And the degree is 2. Okay. So let's go down to 5 through 8, and you guys have done this before. This is just really combining like terms together. So it says add or subtract polynomials. You can only combine them together if they have the same variable and exponents. Okay, so like you can only combine x to the thirds with other x to the thirds. You can only combine x to the seconds with other x to the seconds, and so on. Okay, then you will combine the 2 x's, okay, those x terms together. So all this is combining like terms together. You could also use the vertical method. Some people like rewriting it in a vertical way, and that will look like this, and it's totally up to you. So if I could write it this way, 2x to the third, put the minus 7x to the third under it, and then do the x to the seconds plus 8x squared plus x squared, and this is just rewrite it in a vertical way, 2x and minus 3x. Okay, you can definitely line it up that way, and then you'll have all the terms underneath one another. Okay, if you want to leave it horizontally like it's written, that's totally up to you. Okay, but some people just, they kind of like it already together. So if I have a negative 7 x to the thirds and a positive 2x to the thirds, how many x to the thirds do I have? Negative 5x to the thirds. Okay, because all you do is combine the coefficients together. If I have an 8x to the second and I add one more x to the second, then I have a total of how many x to the seconds? 9x to the seconds. Okay, I have a positive 2x and I take minus 3x away, I have a minus x. Okay, so notice we don't do anything with the exponents. You only add or subtract the coefficients. Okay. All right, so now we're going to do a subtraction one. So I did an addition one. Let's do a subtraction one. Now subtraction is you have to be very careful because this minus sign actually changes all the signs inside of that second set of parentheses. Addition, it does not. Okay, but for a minus sign, that means that's a negative 5, a positive 7 for 7p to the fourth, and a positive 8p to the third, because it's almost like distributing that negative to everything in parentheses. So again, you can either leave it like it is or you can rewrite it vertically. Okay, I'm going to rewrite it vertically, 6p to the fourth. I'm going to change that negative 7p to the fourth to positive 7p to the fourth. Now I'm going to do my p to the third, so I'm going to put plus 5p to the third. Could you stop? Okay, and this is going to be a plus 8p to the third. And then I'll do my constants, plus 7 and minus 5. So I've already changed the signs as I actually put them together. So 6p to the fourth plus 7p p to the fourths will give me a total of 13p to the fourths. 8p to the thirds plus 5 will give me how many? Okay, 13p to the thirds. And 7 minus 5 will give me a plus 2. Okay. So if I did ask you this question, like, what would be the degree of this polynomial? What would you say? 4 is the degree. What would be the name of the polynomial? Okay, a trinomial, because we have 3 terms. Very good. All right, so let's move on. Okay, so in number 9, that's just using the distributive property. Okay, that's another familiar topic that we already know how to take something on the outside, multiply it by something on the inside. Okay, now you just have variables, so you just want to make sure you use your exponent rules here. So a negative 4n squared times a negative 4n will give me a positive 16n to the third, because when we multiply, we add the exponents. A negative 4n to the second times a negative 2 will give me a positive 8n to the second. Okay, and that's all you do. Okay, number 10, a negative 6x times x is negative 6x squared. And negative 6x times 4 is a negative 24x. So that was multiplying a monomial times a binomial. Okay, now we're going to multiply a monomial times a trinomial. Same thing, distributive property. Negative 8 times a negative k squared will give me a positive 8k squared. Negative 8 times a positive 6 will give me a negative 48k. And negative 8 times a positive 2 will give me a negative 16. All right, so let's move on down to number 13. So GCF just represents the greatest common factor. That means what is the greatest number you can divide into 24 and 8? Okay, who can tell me? What's the largest factor that can go into both 24 and 8? Yes. All right, 8. Okay, and you just got to know your multiplication facts for that. Okay, 8 is the largest factor. So what you're going to be doing is picking out the largest number that can go into the coefficients, of course, and you're also going to be picking out the greatest common factor for the variable as well, for the exponents. Because notice it has a v to the second and a v to the fourth. So just think about this for a minute. If I have v to the second, that means v times v. And then I have v to the fourth, that means 4 v's. How many do they have in common? They only have 2 in common. Okay, so you wouldn't have to, particularly do this little pictorial. All you have to remember is if both of them have v's, you always choose the smaller exponent. Okay, so that's really all you have to remember, because that's all they would have in common is the smallest exponent. So this is what you would do. So we know 8 was the largest number. V to the second is the largest exponent. So technically you're dividing both of these by 8v squared. Okay. So this is how we do what we call factoring out the greatest common factor. So now it's going to look like reverse distributive property. So what we're going to do, we're going to put this 8v squared on the outside of the parenthesis, because that's the GCF. And now we're going to actually divide 8v squared into that negative 24v squared. So we know how to divide with numbers. What is negative 24 divided by 8? All right, negative 3. What is v squared divided by v squared? And this kind of helps with our division rule. Okay, that's 0, so we don't need to write anything, because anything to the 0 power is what? 1. Okay, so we don't need to write times 1. All right, now let's go ahead, put our plus sign, And now 8 divided by 8 is 1. I don't need to really write that. But what is v to the 4th divided by v to the 2nd? V squared. And there's your answer. Okay? So if you were to distribute this back out, you would end up back at your original answer. That's how you know it's right. If I actually take the time to distribute this back out, I will come back up with negative 24v squared plus 8v to the 4th. Okay, let's look at number 14. Now they don't have any numbers in common because 7 and 5, they're both prime numbers, so they don't have any common factors. But they do have a common factor for the k. What would it be? Is it k to the 4th or k to the 1st? You always choose a smaller one. K. It'll just be k. So we're going to put the k on the outside, and we're going to divide both of those terms by k. 7 stays. I subtract 4 minus 1, that's k to the 3rd. Okay. For the other term, the k's cancel out. I just end up with 5. If I distribute it back out, I end up with my original problem. Okay, that's how you know you're correct. Okay. All right, we're going to do one more of these. Let's take a look at 17. So I'm looking at the numbers 8, 7, and 7. So again, I don't have any GCF with those numbers. Okay, so the number part, but I do have some GCFs with the variables. So let's look at the x terms first. So what is the smallest power to the x term? X squared, okay. What is the smallest power to the y terms? 6, very good. So that's your GCF. X squared, y to the 6. Okay, so there's your GCF. So again, the 8 is going to stay. I'm going to subtract the x's. They cancel out. Okay. I'm going to subtract my y's. 9 minus 6 is 3. Okay, 7 stays. X's cancel out. Subtract my y's. 7 minus 6 will give me 1. 7 stays. Subtract my y's. They cancel out. And also the x's cancel, the y's cancel, and the x's cancel out. Okay. So that's your answer.